This video is presented to you by www.testprepadda.com. Hello students, as you are watching this video lecture, I believe that you have already watched the previous video lectures of General Organic Chemistry. In this video lecture, I will talk about the application of mesomeric effect. The application part is to determine the acidic strength of phenol and substituted phenols. Here this is the structure of phenol. Experimentally, we decide the acidic nature of the compound with the help of Ka values. So here the Ka value of phenol is 1.1 into 10 raised to minus 10 at room temperature. Therefore, phenol is a weak acid and ionizes slightly in water. When I say it ionizes slightly in water, if you put this phenol in water, it will give phenoxide ion plus H plus. So this is our phenol. This is phenoxide ion. This phenoxide ion is actually conjugate base. So these two are conjugate acid base pair. Now phenol turns blue litmus paper red and reacts with alkali to form phenoxide salt. So if I write the reaction, phenol when treated with NaOH, we get sodium phenoxide plus H2O. Acid plus base giving salt and water. Many times we say phenol is soluble in alkali, that is NaOH. My point is clear? Now, question arises how to explain this acidic character of phenol. Mesomeric effect can help in this matter. Okay, if I write the structure of phenoxide ion, it is this. You can see here lone pair is in conjugation with double bond. So this phenoxide ion will exhibit the resonance. And if I write the resonating structures here, the bond shifting will be in this manner, electronic displacement. So the next resonating structure of phenoxide ion will be this. Then next will be like this. Next it will be like this. And next will be this way. So there are 5 resonating structures of phenoxide ion. So phenoxide ion we can say is resonance stabilized. Conjugate base is resonance stabilized. And since conjugate base is resonance stabilized, on the basis of conjugate acid base theory we can say the parent will be the acidic in nature. Parent will be acidic in nature. But the question arises, if you compare phenol and phenoxide ion, we are saying that this phenoxide ion is resonance stabilized. That is why it is weak base. That is why the parent phenol is acidic in nature. But question arises, if you draw the structure of phenol, in phenol also you can see lone pair in conjugation with the double bond. So phenol will also exhibit the resonance. Here also we can write different resonating structures like this. If I write all resonating structures, let me write all resonating structures first. So these are the 5 resonating structures of phenol. Phenol is also resonance stabilized. If this is stable, how can you say this phenoxide ion is weak base? So the problem is both are exhibiting resonance. Now we have to check which one is more stable. Which one, whether phenoxide ion or phenol, which one is more resonance stabilized? For that, you have to check the resonating structures of phenoxide and phenol. My point is clear. In phenol, you can see 1, 2, 3. There are 3 resonating structures where oxygen has got positive charge. You can see charge separation is there. Charge separation. Charge separation is dipolar. Due to this, resonance stabilization is relatively low. If you look at the resonating structures of phenoxide ion, there are 2 cases where negative charge is on oxygen. Negative charge on more electronegative element. More electronegative element is capable of holding negative charge, so will provide more stability. So, resonating structures of phenoxide ion are more stable than phenol. This is more stable. That is why its parent, that is phenol, will be more acidic. So the acidic property of phenol is explained on the basis of resonance stabilization of phenoxide ion. Now my point is clear. Okay, now I will talk about the substituted phenol. Here I have written all those substituents which decrease the electron density on oxygen. This is the oxygen, will decrease the basic strength of phenoxide ion and will increase the stability of this conjugate base. As a result, acidic strength of parent phenol increases. It's very simple, as we have discussed that acidic strength acidic strength of phenol is because of stability of conjugate base phenoxide ion. So more stable conjugate base implies more acidic parent. So if you're substituting any group, for example, you're substituting group X. If this group X is electron withdrawing, it will decrease the electron density of this O. If electron density on O decreases, it will become weaker base. Weak base means more stability. More stability here means parent will be more acidic. Okay. Now to understand this, I'll take an example here. Consider this compound. This is para nitrophenol. This is para nitrophenol. Now to check the acidic strength of para nitrophenol, I will write the conjugate base of this, and that is this phenoxide ion. Now let me tell you that NO2 is actually a minus M effect group. A minus M effect group. Negative mesomeric effect. Now what is this negative mesomeric effect? This is electron withdrawing group. This is electron withdrawing through resonance. Resonance. Okay, this is electron withdrawing through resonance. Although it is minus I effect group also. Minus I effect is also electron withdrawing, and that is through the inductive effect. But we know mesomeric effect gets preference over inductive effect in majority of cases. That is why here I am talking about mesomeric effect only. My point is clear. So NO2 is minus M effect group. It will pull the electrons through resonance, and that is why the electron density of this oxygen decreases. Electron density decreases. Electron density decreases means it is weak base now. Weak base means its parent will be stronger acid. So if I compare this with normal phenol, the conjugate base of this phenol is more stable as compared to this. That is why para-nitrophenol will be more acidic than normal phenol. This is the acidic order. This is the acidic order. Now if I take another example here, this is para-methoxyphenol. Para-methoxyphenol. Now to check the acidic strength of this phenol, again I'll write the conjugate base, and I will check the stability or the basic strength of this conjugate base. Now here let me tell you that this CH3O, this is plus M effect group. This is plus M effect group, means electron releasing through what? Resonance. Electron releasing through resonance. Although it is minus I effect group also. Minus I means electron withdrawing through inductive effect. But as I told you, mesomeric effect gets preference in most of the cases. That is why I am talking about mesomeric effect only. Okay, so this CH3O will shift the electron in this manner, and this way the electron density on oxygen increases. So if I compare this oxygen with the normal phenoxide oxygen, here the electron density is more, so it is a stronger base, so its parent will be a weaker acid as compared to the normal phenol. So Paramethoxy, paramethoxyphenol is less acidic than normal phenol. I am writing this for acidic strength. My point is clear. Now, if I take another example, metanitrophenol. This is metanitrophenol. Now, as we know, NO2 is minus M effect group. NO2 is minus M effect group, means electron withdrawing through resonance. But if you recall the video lecture of mesomeric effect, there I told you that there is no effect, at meta position. And if I write NO2 here, then this is actually meta with respect to attached NO2. So, NO2 will not decrease the electron density at this position. So if I write the phenoxide ion, then NO2 will not be able to change the electron density of this oxygen because this is at meta position. And this I am telling with respect to mesomeric effect, resonance. My point is clear. So, no effect of resonance. But at the same time, this NO2 is minus I effect group. So it is electron withdrawing and this is distance dependent. So due to minus I effect, it will withdraw electrons. So if I compare with the normal phenol, here the electron density will be less. But that is only because of inductive effect, not the mesomeric effect. So here also meta-nitrophenol will be more acidic than normal phenol. So if I take all the examples which I discussed here, like normal phenol, like para-nitrophenol, like para-methoxyphenol, like meta-nitrophenol. So here in this second case, NO2 is minus MFA group as well as minus IFA group. So this phenol will be the most acidic phenol. And out of these, in this case, the electron releasing group OCH3 plus MFA group. So this will be the least acidic phenol. And that is why if I try to write the order, and number this 1, 2, 3, 4. So the most acidic is 2, then it is 4. Although in 4 there is no resonance, there is no mesomeric effect, but because of inductive effect, it is more acidic than the normal phenol. So here 1, the least acidic is this number 3 because here OCH3 is electron releasing through resonance. So this is the correct order for these compounds. My point is clear. So this is all about the acidic strength of phenol and substituted phenol. If the substituent is electron withdrawing through resonance, it will increase the acidic strength of phenol. If the substituent is electron releasing with respect to resonance, it may decrease the acidic strength of phenol. Okay, students, in the next video lecture, I will talk about the comparison. Of acidic strength of alcohol, phenol, and carboxylic acid. So must watch that video. Thank you. This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals.
Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.